Hello everyone, this is Dr. G.K. Sandhya from SRM Institute of Science and Technology. Today we are going to discuss about the topic called Model for Network Security. So under cryptography and network security. So we'll start with the model for network security. So model this model represents the message can be transferred from one end to other end through some information channel or communication channel. So here the two parties will be exchanging the informations from one end to another end using some protocol, say for example TCP/IP protocol or UDP protocol, with the help of some principles here. So your original message, the sender used to send some information to the receiver. So the original message will be taken as a transparent text. So that information will be given to a algorithm, or we are going to provide security using some algorithm for that message. So here security related transformation will be done in this part. That means either I am going to use some algorithm or some technique for transferring the original message to secure message. So we need some secret information, or we need some kind of key in order to transfer the message, or in order to encode the message from transparent message to unintelligible form or encoded message. So using some algorithm along with the key, I will be transferring the message to some other form, that we can call it a secure message, or I can call it a ciphertext. So that text will be sent to the recipient or receiver at the other end through some communication channel. Here they are calling it as an information channel. So that information channel used to carry the information that is in the form of encoded message, encoded information, or we can call it a ciphertext to the receiver. So at the receiver end also we have a secure message. So that ciphertext, or we can call it as encoded message, that message will be given to the decryption algorithm. That algorithm will convert the original message to the plain text. So the plain text or the message in the transparent form we can be received at the receiver side. So this is the general model for network security. So if suppose we have any opponent or hacker or attacker in the middle of the transaction or communication, then we can call it as a opponent or hacker. So if he sits in the middle of the transformation or transmission of the message also, he cannot decrypt the message, because we are using some algorithm or technique to encode the message. So we need some trusted third party server or distributor or some channel in order to protect our messages. So we have to use some preliminary terms before we start the communication. We have a plain text, that is original message, or we can call it as a transparent message, or intelligible readable content, we can call it as plain text. Ciphertext is some coded message or encoded information or unintelligible information, we call it as ciphertext. And cipher is nothing but an algorithm for transforming the plain text to ciphertext. Some technique we are going to use for converting the plain text to ciphertext is cipher. And the key is a unique value or some random numbers used to convert your plain text to ciphertext. That key will be used at the sender as well as by the receiver. And encipher we can call it as encryption or encrypt, which converts the plain text to ciphertext. And decipher is a algorithm or a decryption, the other name. So that technique will convert the ciphertext to plain text. And we have a new terminology called cryptanalysis. So the cryptanalysis is a process of breaking the key and the algorithm, we can call it as cryptanalysis. The person who does this job, we can call it as cryptanalyst. And cryptography is study of all the encryption and decryption methods, we can call it as cryptography. And cryptology is the field of both cryptography and cryptanalysis, we can call it as cryptology. And next we have so for modeling the network security, we need some requirements. That is, first one is very foremost thing here is we need some suitable algorithm for converting your original message to some encoded message. And second thing is we need to generate some secret keys in order to protect our message. And third thing is we have to develop some methods to distribute or share the keys or share the secret information among the sender and the receiver. And finally, we have a protocol. We need to specify which protocol will support our algorithm as well as the secret key. So these are all the basic requirements before we start with modeling the network security. So basically we have two kind of encryption techniques. One is symmetric key encryption, the other one is public key encryption. First and foremost algorithm is symmetric key encryption. So this is very old technique. So all the classical encryption techniques will follow this kind of algorithm, symmetric key encryption algorithm. The other name for symmetric key encryption is conventional key cryptography, or we can call it as private key cryptography, or we can call it as single key cryptography, because it uses only one key for encoding and decoding, or encryption and decryption. So sender and recipient will share the same key. Common key will be used between the transactions. So we can call it as a single key encryption technique. So all the classical encryption algorithms are private key, that is, or uses only one keys, and this was developed before inventing the public key cryptography. I'll tell you what is the public key cryptography later. So this is the model or structure of a symmetric key cryptography. So here we have as plain text, and that plain text has to be converted to some other form using the encryption algorithm. Say for example DES. DES is data encryption standard. This is one of the example for symmetric key cryptography that uses only one key, that is common key, will be used by the sender as well as by the receiver. So that key has to be transmitted through some secure channel before we share the information. So using that algorithm, that is encryption algorithm, along with the key, we are going to convert the message to some other form, that is ciphertext. So what a ciphertext is? The encrypted form of your original message, or the encoded form of your original message is ciphertext. So that text will be generated based on the algorithm we are going to use, and we have two inputs here. One is that is for converting the plain text to ciphertext, we need two things. One is algorithm, the other one is key. So the ciphertext will be transmitted to the receiver. Receiver will get the ciphertext. Again, at the receiver side we have a decryption algorithm. So that algorithm also works with the help of two inputs, that is, you will be having ciphertext. Ciphertext is used along with the key and the algorithm in order to convert that to plain text. So this is a working model of symmetric key cryptography. Here also we have some requirements, that is, in order to secure the symmetric key encryption algorithm, we need strong encryption algorithm, so that whatever the information we are sharing between the sender and the receiver to be confidential in nature, and we have a secret key that is known only to the sender and the corresponding receiver. So for generating the key or for generating the encrypted text, we have to use some mathematical concepts in order to increase the security. So assume encryption algorithm is known to both the sender and the receiver, and we have to distribute the key through some secure channel in order to increase the security. So always the strength of the cryptography relies only on the type of the encryption technique we are going to use, and number of keys we are going to use, and finally how the plain text is processed. So if I say type of encryption operations, either we are going to use substitution technique or transposition technique or some product based techniques. Substitution in the sense, instead of one character or one symbol, I am going to replace another character or another symbol. If I say transposition, just I am going to change the position of the characters or position of the letters which is given in the plain text. And if I say product, I am going to take the product of the values or the alphabets or the letters I am going to use. So using any one of this operation, I can convert the plain text to ciphertext. This is the encryption operation they are going to use. And next strength of the encryption is, or cryptography is, number of keys which we are going to use. So whether it is single key or whether it is a public key encryption. If I say public key, we are going to use two keys. One can be called as public, the other can be called as private. So I'll tell you that later. So next thing is the way in which the plain text is processed. That means whether we are going to take the plain text in the form of block ciphers or in the form of stream ciphers. If I say block of bits will be used for conversion. If I say stream, bit by bit transactions or transmission will be done. So this is the strength of the symmetric key encryption. And finally we have cryptanalysis. What is cryptanalysis is, the cryptanalyst will do cryptanalysis. The cryptanalysis is process of breaking either the algorithm or the key in order to identify the message which is being transmitted. So we have two basic attacks here. One is cryptanalytic attacks, the other one is brute force attack. So cryptanalytic attack is identifying the algorithm or the process of conversion, the process of converting the plain text to ciphertext and vice versa. We can call it as cryptanalytic attack. And brute force attack is using some trial and error method, we are going to identify the key. So that's all about the symmetric key encryption. In the next video we are going to discuss about the asymmetric key cryptography or public key cryptography. Thank you.